Okay students, let's go through the steps of Breusch-Pagan test of heteroscedasticity. Suppose we are running this regression model involving k explanatory variables, and under the assumption, the null hypothesis, we say that all the errors are distributed with same variance, that is sigma square. So how can we test whether this assumption holds or not? In this case, we can use the Lagrange multiplier test or the F test. In one of the earlier videos, I have discussed the various steps of Lagrange multiplier test and F test. So in this particular video, let's modify those steps to test for the heteroscedasticity, or test for the whether homoscedasticity assumption holds or not. In this Lagrange multiplier or F test version, the first step involves running the usual regression model as usual and obtain the OLS residuals as u hat square. आपको ये regression run करना है and obtain the residuals and square them. In the second step, which we call auxiliary regression, run this squared residual on all the explanatory variables, that is x1, x2, so on up to xk. Then under the null hypothesis of homoscedasticity, we say that all these delta 1, delta 2, so on up to delta k are statistically equal to 0. And the alternate hypothesis, we say there is an evidence of heteroscedasticity. From this regression, obtain the r squared of u hat square. I have noted it down like this. Okay, then calculate the LM stat in this form, and then when check it with like in the chi-square table, and this is LM is chi-square distributed with k degrees of freedom. If the p-value is very small, then you say that the null hypothesis is rejected. If p-value is large, then you say that we fail to reject the null hypothesis. Okay, and similarly, from not only you can calculate, or you can go with the LM stat, and the LM stat version of this statistic is termed as Breusch-Pagan test of heteroscedasticity. And you can also calculate the F test version of this statistic from this R square by calculating this, and this is distributed, F distributed with k, n minus k minus 1 degrees of freedom under the null hypothesis of homoscedasticity. In this case, and the restricted model will be running the u hat square on intercept only, and the unrestricted model will be running this entire model. Okay, that's how you can calculate whether there is homoscedasticity.